Hello students, today we'll discuss a very important topic which is correlation. Today is lecture number 26, Introduction to Correlation, and this is Correlation Series Part 1. I am Dr. Muhammad Zahir. Before we discuss correlation, let us discuss what is linear relationship. Suppose if x and y are the two variables, form a line when graphed. That is, y changes by a constant amount every time x increases by 1 unit. We say that there exists a linear relationship between the two variables. You must remember that whenever we discuss independent and dependent variables, y is generally taken as the dependent variable and x is taken as independent variable. There are three numerical measures of linear relationship that provide information as to the strength and direction of a linear relationship between the two variables if one exists. These are the covariance, the coefficient of correlation, and the coefficient of determination. Let us discuss them one by one. Covariance. See, this is an example in which we have got three types of data sets. In set number 1, see x is 2, 6, 7 and y is 13, 20, 27. You can see in second data set same are the numbers, and in third data set same are the numbers, but the order of dependent variable is changed. Here in set 1 the dependent variable is 13, 20, 27. In set 2 it is 27, 20, 13, and in set number 3 it is 20, 27 and 13. We have changed the order, and we have calculated the covariance in three data sets. In set number 1, as x increases, so does y, and the covariance is a large positive number. You can see x is increasing to 6, 7, 13, 20, 27 are the values of y which are also increases, and it is 17.5. And in set number 2, as x increases, y decreases. X is increasing 2, 6, 7, y is decreasing 27, 20, 13, and we have a large negative number which is minus 17.5. And in data set 3, as x increases, y doesn't move in any particular direction, so covariance is a small number. So when two variables move in the same direction, both increase or both decrease, the covariance will be a large positive number. When two variables move in opposite direction, the covariance is a large negative number. And when there is no particular pattern, the covariance is a small number. However, it is often difficult to determine whether a particular covariance is large or small, which value should be considered as small or which value should be considered as large. So the next parameter, the statistic, addresses this problem, and this is coefficient of correlation. This coefficient answers the question, how strong is the association between x and y between two variables, independent and dependent variables. The advantage of the coefficient of correlation over covariance is that it has a fixed range from -1 to +1. Thus, if the two numbers are very strongly positively related, the coefficient value is close to +1, showing strong positive linear relationship. If the two variables are very strongly negatively related, then the coefficient value is close to -1, that is strong negative linear relationship, and no straight line relationship is indicated by a coefficient which is close to 0. And the third one is coefficient of determination. We can judge the coefficient of correlation in relation to its proximity to -1, 0 and +1 only. However, we are fortunate enough to have another measure that can precisely interpret it. It is the coefficient of determination, which is calculated. The coefficient of correlation, for this reason we denote it with r square. The coefficient of determination, or R square, measures the amount of variation in the dependent variable that is explained by the variation in the independent variable. It means if we change independent variable, there is a variation or change in the dependent variable. For example, if we have R square equal to 0.58, it tells us that 58% of the variation independent variable is explained by independent variable. You have to multiply 0.58 by 100. The remaining 42% is unexplained. So today's basic topic is correlation. Hope you have understood the linear relationship. Now we discuss correlation in detail. The term correlation represents a series of statistical tests that measures the relationship between two variables. Correlation is a statistical concept that measures the strength and direction of the relationship between the two variables. You must note two things: direction and strength. We'll see. Usually two variables are simply observed as they exist naturally in the environment. There is no attempt to control or manipulate the variables. So we are not going to do anything with independent or dependent variable. We just observe, calculate their values, and we calculate correlation coefficient. Correlation can be positive, negative, or zero depending on how the variables change together. This is the example of positive correlation. You can see this straight line which is having this slope in the positive side. We have taken the example of sales and temperature. A positive correlation means that as one variable increases, the other variable also increases. For example, sales of cold drinks increase as the temperature increases. You can see that sales are increasing as temperature is increasing. Negative correlation, this would be like this, a straight line showing a negative relationship. A negative correlation means that as one variable increases, the other variable decreases. For example, sales of tea or coffee increase as the temperature decreases. And no correlation, a zero correlation means that there is no linear relationship between the variables. For example, increase or decrease in the temperature doesn't affect the sales of computers. You can see there is no pattern given. You cannot see any particular pattern that if temperature is increasing, the sales of computers is also increasing or decreasing. So correlation is useful for exploring and describing the patterns and associations between the variables. However, correlation doesn't imply causation. Means that just because two variables are correlated, it doesn't mean that one variable causes the other. To establish causality, one needs to conduct experiments or use other methods that can control for confounding factors and test for alternative explanations. There are certain types of correlations. First one is the Pearson's correlation, which is most widely used. Then there is Spearman's correlation, then Kendall-Strawbee, partial and semi-partial correlation, biserial correlation, and point biserial correlation. Now see which type of correlation is used in which particular situation. Pearson's correlation is used when both variables are parametric. Spearman's correlation is used when at least one of the variables is not parametric. Kendall-Strawbee is used instead of Spearman's correlation if there are too many tied ranks. And point or biserial correlation is used when one of the variables is categorical. Assessing the correlation. How we assess? There are generally two methods or two techniques. One is graphical technique. We use scatter plot, and other is correlation coefficient value. Interpreting the correlation coefficient according to Cohen's 1988 formula. If the value of R is 0.10 to 0.29, we say that the relationship is weak or the strength of relationship is small. Similarly, if it is 0.30 to 0.49, the relationship is strong. And if it is 0.50 to 1, we say that the relationship is very strong. Key points to remember. Rarely we find perfect correlation. There are individual differences and other factors that may interfere with observed relationships. Negative correlation is not bad. It is simply describing the direction of the relationship. It doesn't mean that there is no relationship because it is less than zero. Correlation never implies cause and effect relationship, as told earlier. Don't put too much emphasis on significance in large samples. Focus on the correlation coefficient. This is very important. You must not put too much emphasis on significance value. Put the significance value aside and see the strength of the correlation coefficient, and always report significance with the coefficient in smaller samples. Smaller samples means any sample less than 30. Be careful with interpretation. Correlation doesn't predict cause and effect relationship. Range of values affect the results. Outliers greatly affect correlation results. Do check coefficient of determination to be on the safer side. When you are having hypothesis testing, we use H0 as the rho equal to 0, which shows that there is no population correlation, and H1 rho is not equal to 0, there is a real correlation. And specific hypothesis, when there is a specific prediction about the relationship of the correlation, it is possible to do a directional or one-tailed test. For example, if a researcher is predicting a positive relationship, the hypothesis would be H0 is rho is less than or equal to 0, the population correlation is not positive, and rho is greater than 0, alternative hypothesis, the population correlation is positive. When we are going to interpret the SPSS output, first see the scatter plot, check for outliers, check the information regarding sample size and missing values, determine the direction of the relationship, whether it is negative or positive. Positive shows as the same direction and negative shows inverse direction. Calculate the coefficient of determination. Look for the significance value important. I hope you would have learned today what is correlation, how the results of the correlation are interpreted, what is a linear relationship. In the next video, we will see what is Pearson's correlation. Till then, thank you very much. Take care.